In Part 2, we will focus on measurable properties of the atmosphere that are used to determine weather for specific areas. Temperature is the measure of the motion of the molecules in a substance. In hot air, the molecules are moving very quickly, and in cold, the molecules are moving less quickly. Think about when you are running around the track. You are moving fast and you're getting hot quickly, and once you stop running, you begin to cool down. Temperature is measured using a thermometer. Most commonly, temperature is measured in degrees Celsius or degrees Fahrenheit. Provided to you are the conversion equations. In degrees Fahrenheit, water will freeze at 32 degrees Fahrenheit and will boil at 212 degrees Fahrenheit. In degrees Celsius, water will freeze at 0 degrees Celsius and boil at 100 degrees Celsius. Both scales will measure the same temperature at exactly 40 degrees. Once molecules stop moving, that is as cold as it can get. Absolute zero is measured at negative 270 degrees Celsius and negative 459 degrees Fahrenheit. The greenhouse effect is the heating of the Earth's surface and atmosphere from solar radiation being absorbed and emitted by the atmosphere. About 50% of incoming solar radiation is absorbed by the Earth's surface. Most of the molecules in the Earth's atmosphere do not absorb visible or shortwave radiation. The Earth's surface warms and emits energy in the form of long-wave radiation, which is invisible to the human eye. Certain molecules in the atmosphere, mostly water vapor and carbon dioxide, do absorb the infrared radiation. This is what warms the Earth. For a better understanding, watch the following clip. Humidity is the amount of water vapor in the air. Three sources that contribute to the moisture in the air are evaporation from bodies of water, transpiration from the leaves of plants, and activities from animals such as sweat and exhalation. The amount of water vapor that the atmosphere can hold depends on the temperature of the atmosphere. When the temperature increases, the ability to hold water increases. At any given temperature, the amount of water vapor the air can hold is limited. The maximum amount it can hold is its capacity. When the air is at its capacity, it is said to be saturated. When we talk about relative humidity, we are comparing the amount of water vapor actually present in the air with the maximum amount of water that the air can hold at a specific temperature. For example, a parcel of air that is 50 degrees Fahrenheit has a capacity of 400 grams of water. If it is filled to its capacity, it is saturated. If it is holding only 200 grams of water, it is at half capacity, or 50%. This comparison expressed as a percentage is called relative humidity. Dew is the water vapor that has condensed on a solid object. The grass, your car, your windows, even your cup. The dew point is the temperature at which water vapor begins to condense. This will depend on the amount of water vapor present in the air and the temperature of the air. Once the air has reached the dew point, the water vapor in the air has decreased to the point where it condenses into a liquid. Frost is simply dew in the winter. Frost will form from a gas directly to a solid. We have learned that in the troposphere, as altitude increases, temperature decreases. Clouds are going to form high in the sky when the water vapor begins to condense into tiny droplets around condensation nuclei. Condensation nuclei are small particles of smoke, dust, or salt in the atmosphere. When water vapor condenses just above the surface of the earth, it is called fog. There are many types of clouds. Clouds will be classified and named based on their shape, height, and sometimes rain capacity. The three main cloud types based on shape are stratus, cumulus, and cirrus. Stratus clouds form a smooth, even sheet, usually forming at low altitudes. Cumulus clouds are masses of puffy white clouds, often with flat bases, usually forming when warm air rises. They can be associated with both fair weather and thunderstorms. Cirrus clouds are high, thin, white, feathery clouds that contain ice crystals. Cirrus clouds are usually associated with fair weather, but they also may indicate approaching storms. The prefix of cloud names can describe the height of a cloud base. Cirro referring to high clouds, alto referring to middle height clouds, and strato referring to low-level clouds. Nimbus clouds are dark colored and associated with precipitation. When a nimbus cloud is also a towering cumulus cloud, it is called a cumulonimbus cloud. Please make sure that you copy, learn, and understand the following steps in cloud formation. First step is air is going to rise up and increase in altitude. Step 2, it is going to begin to cool as it increases in altitude. Step 3, as air reaches the dew point, it's going to begin to condense. Step 4, a condensation nuclei must be present for the water to condense on. Step 5, condensation will occur and clouds begin to develop. Precipitation is any form of water that falls to Earth's surface. The type of precipitation that falls to the ground depends on the formation process and the temperatures of the environment between the cloud and the surface. Rain will develop when growing cloud droplets become too heavy to remain in the cloud and fall to the surface. Snow is formed when ice crystals form from water vapor and is in the clouds. Sleet is frozen raindrops. It begins as rain or snow and falls through a deep layer of cold air that contains temperatures below freezing near the surface. Hail is formed when updrafts carry raindrops upwards into extremely cold areas of the atmosphere, where the raindrops merge and freeze. When the frozen clumps become too heavy, they will fall to the surface. Here you will find a chart that will tell you what each weather instrument is designed to measure. The barometer measures air pressure. The psychrometer measures relative humidity. The wind vane will measure wind direction. Thermometers measure temperature. Anemometers measure wind speed, and rain gauges will measure how much rain falls in a specific area. Along with your notes, you received a sheet of paper with a picture of each of these tools. Please cut them out and glue them next to the correct atmospheric property that it measures.